Okay, I'm going to do a short explanation on the topic of binomial expansion. So you can flip to your textbook. I'm going to use some examples there, starting from page 161. Okay, along the way, if you want, you can stop. You can pause the video, or I'll just go on and explain. Binomial expansion, why do we need it? Okay, basically because we need expansions for factors to the power of something. So the simplest one that you have learned will be a plus b squared, which by now you should know is a squared plus 2ab plus b squared. Okay, then what is a plus b cubed? It should be a cubed plus 3a squared b plus 3ab squared plus b cubed. How do I know the answer so fast, right? Because you can use the textbook. Okay, so okay, what I'm trying to say is, okay, for expansions involving two terms, okay, within a factor, two terms within a factor, there is a definite way of how your expansion will look like. Okay, so you look at the coefficients. Okay, this is 1, 2, 1. Okay, 1, 2, 1. For an expansion up to square, okay, when you have an expansion up to cube, okay, you have 1, 3, 3, 1. And so on and so forth, as you can see from your textbook, okay, on page 161. So you will notice there's a pattern to the coefficients, depending on what is your a square, what is your a and your b. But the coefficients will always be involving all these 1, 2, 1, 1, 3, 3, 1. Okay, so in binomial expansion, you will learn the definite way of expanding your factors instead of expanding one by one. For example, like expanding a plus b cubed. If we do not know how to expand by binomial expansion, usually we'll do it this way, right? Then we expand the a plus b square. And then we expand further using the rainbow method, right? So binomial expansion will make the process faster. Okay, so how do we expand by binomial expansion? So let me give you an example. 2 plus x to the power of 10. For binomial expansion, there will be several terms. Okay, so usually I will expand it like this. To each term, there will be 3 parts. Okay, the first part of each term, okay, will be formed by this first number over here. So it will be starting from 2 to the power of 10. Just observe the pattern. 2 to the power of 9 plus 2 to the power of 8 and so on and so forth. Okay, that's the first part. Then the second part, for my style, usually I will put 10, choose 0. Okay, then the next one will be 10, choose 1. I'll explain what is this 10, choose 0, 10, choose 1 later. And 10, choose 2. Okay, then the third part will be involving your x. Okay, x to the power of 0, x to the power of 1, x to the power of 2. Okay, in your IGA math, I believe you should have covered this, so this one will be a refresher. So when I expand it, also this 2 to the power of 10 will be a large number. Then you just press a calculator. What is 2 to the power of 10? What is 10 choose 0? So on your calculator, you have something that looks like this. NCR. Okay, so go and press your calculator, 10 choose 0, and you will show the number, and s to the power of 0. So a few observations. This 10 comes from here. Okay, these two numbers will add up to 10, and it's always the case for each individual term. Okay, it will add up to 10. So it's a good way for you to check whether your expansion is correct or not, and go and expand your binomial expansion. Okay, so what other things that you need to know? First thing is 10 factorial. So sometimes you see the exclamation mark. Okay, so 10 factorial represents 1 times 2 times 3 times 4 times all the way until 10. Okay, so this is 10 factorial. Okay, then you just now I mentioned, okay, I will explain this to you, right? So what is this 10 choose 0? What is this 10 choose 1? Okay, previously in the introduction, okay, we have all the coefficients, right? Coefficient of 1, coefficient of 2, coefficient of 1. So these coefficients can be found by using this, whatever that expansion is. So if you want the first one, okay, so actually this coefficient will be 2 choose 0. This number 2, you got it from 2 choose 1. Then this one from 2 choose 2. So if you want, for example, this one, this number 3, okay, this number 3 you got it from, because it's power 3, so it will be 3. 3 choose, this one is the 1. Okay, this one we start from 0, so this will be, the coefficient will be 3 choose 0. The coefficient will be 3 choose 1. This coefficient will be 3 choose 2, and so on and so forth. This will be 3 choose 3. Okay, so notice a few patterns. So now you know what is this 10 choose 0, 10 choose 1. Note it starts from 0. Okay, so what else do you need to know? This we call it the first term. This we call it the second term. Why do you need to know this? Because sometimes in a question they will ask like find the second term, find the third term without expanding. So you are supposed to create this right from the start without expanding the rest. So you need to know what numbers to start sub in. So if they say it's the second term, then it will be x to the power 1. Okay, so you notice the numbers. Second term you minus 1, so that is x to the power 1. Okay, and you know this 1 add up with the 9 to become 10. So you know this will be 9. So there are some questions that you need to know the second term, what numbers that you substitute into your expansion to find a particular term. Okay, so that's our first term, second term. What else do you need to know? So you have this 10 choose 0, 10 choose 1, right? In calculation, how do you find it? If you don't have a calculator, can you calculate out this 10 choose 3? Okay, answer is yes, of course. So how to find 10 choose 3? Notice the pattern and you will understand. Of course, there's a formula for it. Okay, but you just need to know how to execute it. So 10 choose 3 is 10 times 9 times 8 over 1 times 2 times 3. So the bottom is 1 times 2 times 3. And the third, and on top, there will be 3 terms also. So if it is n choose 3, there are some questions that will be the power will be in terms of n. Okay, so you must know what is this n choose 3 so that you can form equations, sub it into your equations later. So n choose 3 will be n times n minus 1 because it decreases in order over 1 times 2 times 3. It decreases in order 1 by 1. That's why it starts from n. Then goes down to n minus 1, goes down to n minus 2. Okay? So some other things that you need to know. Okay, for example, constant term. Constant term, that means in your expansion, okay, there is a term without any x. Okay, so it's just a number without any x. Or you can treat it as you have x to the power 0. Okay, just bear that in mind. Term independent of x is the same as constant term. It just means a number. It also means like x to the power 0. Okay, they are all the same. So I'm just going to show you one example, and okay, maybe 1 or 2. Okay, so page 172, question 3 of your textbook. So you have this expansion. The question asks you to find the first 3 terms. Okay, so what are the presentation to take note? If you write like this and you are going to expand, okay, you must end up with a plus dot dot dot. Okay, so what do I mean? So I'm going to expand as per usual. Okay, 3 to the power 4 plus 3 to the power 3 plus 3 to the power 2. The first term will go down in descending order for the power. Okay, Then you have your 4 choose 0, 4 choose 1, 4 choose 2. And the third piece, okay, notice there is a minus in front of a 5x. So the third part of each term, okay, you must include the minus. So it's minus 5x to the power of 0. So notice again, same power. This adds up to 4. Okay. Minus 5x to the power of 1. Minus 5x to the power 2. Okay, so the expansion have other terms. So you represent it using a plus dot dot dot. Clear? Why am I asking you clear? Okay, but anyway, you have to represent it with a plus dot 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 because there are other terms in the expansion. Okay, so if you don't like to write dot dot dot, okay, you can. But in front, you must write first 3 terms of your expansion. Okay, then you don't have to write plus dot dot dot. Also, it's either or the presentation. Then you go and evaluate. Okay, what are the terms? Okay, so that's for part A. Part B. By choosing a suitable value of x, use your answer from part A to find an approximation for 2.995 to the power of 4. Okay. So in other words, they ask you to hence or use part A to go and solve your part B, right? So it must be related. So both questions is to the power of 4. So you notice this is to the power of 4, this is also to the power of 4. So in other words, you need to find the value of x such that this will end up as 2.995. Okay, so if the question gets too complicated, this is still observable. Actually, from here straight away, I know the answer for x that you have to substitute in is 0.001. Okay, but if it gets too complicated, you know they are of the same power. You know this must be the same as this. Then in your rough working, you simply let 3 minus 5x equals to 2.995 because they must be the same, right? And you just have to work out the x value. So bring over, it becomes 0.005 equals to 5x, then x will be 0.001. Okay, so just do this in your rough working. Okay, so this is the same as 3 minus 5 times of 0.001 to the power of 4. Okay, so in part A, you have already gotten the 3 terms, the first 3 terms, right? So you will just replace whatever that appears over here, your x, replace them with 0.001. And then you will get the answer. Okay? So that's a simple application of your binomial expansion. So what is the next or probably the last important thing that you must know? Okay, can you flip to page 168 of your textbook? Okay, 168 of your textbook. I'll just use the textbook to go and explain to you. Okay. So on page 168 of your textbook, okay, your worked example 7.7. Worked example 7.7. Find the coefficient of x to the power 5 in the expansion of this, right? So if you are going to expand this and then go and find out what is the x to the power 5, it's going to take more than the allocated time that you are given to solve the question. So what's an efficient way of solving this question? You look at the solution. Okay, each term will be of the form of this. Okay, why each term will be of the form of this? Okay, because in your usual expansion, you notice all these terms follow a certain pattern, right? This decreases in order. So if I let's say call it a general term, we call it a general term. to represent each term, okay, in general, it's the same as having 4 to the power of 4 minus r, right? I call it the r term, the r plus 1 term, the r plus 1 term. So it will be 3 to the power of 4 minus r, 4 to the power of r. Why is this r? Because it increases in order, right? So I call it r. And this also increases in order, so I call it r also. So in this case, it will be minus 5x to the power of r. Okay, let me write it again. The r plus 1. The r plus 1 term, that's what we call it, or we call it the general term also. It will be, for this case, 3 to the power of 4 minus r, because it descends in order from 4, right? And 4 choose r, negative 5x to the power of r. This r because it ascends in order, right? So that's why in the book, each term will be of the form, okay, for this example, of this, where 7 follows the power, okay, then 2x squared is to the power of 7 minus r, because the first term decreases in order. Then the next one, minus 1 over x is minus x to the power minus 1, because you bring it up, right? And to the power of r, because it's in ascending order. Okay, so each term will be of this form. Why do I want to present in this form? Because I know if I want coefficient of x to the power of 5, this power 5 I can compare with the power I get when I expand this term. So if I go and simplify, I'll get x to the power of 14 minus 3r. Okay, and I want x to the power of 5. Ultimately, I want it to end up as x to the power of 5. So I will equate 14 minus 3r with 5. 14 minus 3r equals to 5. Right, on the next page. So r equals to 3. You don't have to bother about the coefficient, because ultimately you just want to end up with like x to the power of 5. So you just compare the power, because you are comparing with simply x to the power of 5. You are not comparing with the coefficient or whatever. It's just making use of the power, to find what is the particular r that will end you up with x to the power of 5. Okay, so that's why we just compare the power only. So you work out r equals to 3, then you will work out what is the coefficient. That's why you have this working. And then blah blah, then you will get the coefficient as minus 560. Okay, so basically that's all the important things that you must know about this chapter. Okay, hope this helps.